All right, good afternoon, everyone. Welcome to today's Tech CLP, where Robson is going to give us a talk on Kotlin on the back end. All right, over to you, Robson.
Hi, everyone. I'm Robson Cassiano. I'm from Brazil. Today, I'm going to show you guys some concepts from Kotlin language and also some real code from a service that I own. So no problem showing the code to you guys. And it's in production since last year, so it's well tested. It's going to be fun. Let's start. Can you see my screen?
Yep.
Okay, so real-world Kotlin on the back end. Usually people tend to think that Kotlin is only for Android, but that's not the case. We can also create backend applications with Kotlin, and also it can generate code for iOS and Android, as everyone knows, and even for the front end with WebAssembler, or it can even generate JavaScript code if necessary. I haven't done that yet, but it's possible. Some people use that for this purpose. And I have a quick analogy here. So usually people that came from Java and it is migrating to Kotlin or needs to use Kotlin at work somehow because the company asks for that, there is no problem at all because they are fully compatible between themselves. I only draw a distinction here. Java is like driving a stick shift car, and Kotlin is like driving an automatic transmission car. So, and both of them use the same engine, which is the Java platform. And it's available almost 10 years now. So since the first stable release in 2016. And it's backed by Google, backed by another giant companies, so it's not going to disappear out of nowhere. It's one of the reasons why Kotlin is so strong right now with Android. It's because of Google, because of some legal concerns regarding the Java itself. The Java code, Oracle likes to be a troll sometimes, or most of the times. So Google doesn't want to have to deal with Java code directly for everything. And they saw in Kotlin a solution that was already created, already in production in the real world. And they just said, we want Kotlin as the default for our Android applications. We still can use Java, but they strongly suggest that we use Kotlin for Android. But as I said, it's not only for Android. We can do backend and other stuff with it with no problem. I have put here at the top left Java and Kotlin to emphasize that they are really the same thing. It's almost like TypeScript for JavaScript. So it's not a huge transition. It's like a synthetic sugar that's really useful, that's really well tested. So it's not like a huge difference. It's just like a shell around the Java code. It's a bunch of extension functions that does a really good job of increasing productivity and making the syntax more clear. The creator and the main engineer behind Kotlin said that they have learned from the previous giants. So there is a really good talk from him called or titled On the Shoulders of Giants. It's really interesting. He mentions all the language that they draw inspiration from when they were creating the Kotlin language. So it's not a big difference, but also it's a modern approach to the syntax. But at the end of the day, they are both the same engine. and the transition between them is really easy. We can learn them in. I think I haven't done that exhaustive tests on that, but at least from my own experience, so one evidence at least, it's a couple of hours to learn Kotlin. If you already have learned Java and use it before, you can be productive in Kotlin in a few hours of study. And yeah, there is deeper parts, deeper frameworks and things that we can do with Kotlin. It will take a few days or weeks to learn them, but to be productive in production in the team, a few hours, you are ready to go. So just some specifics about Kotlin. So drastically reduce the amount of boilerplate code compared to Java, which is famous exactly for that and other things. Its concise, expressive syntax allows team to focus on business logic, writing less to achieve the same result, which speeds up development and simplifies maintenance. That's really true. I have worked in one of the biggest Brazilian banks here in Brazil. It serves around 50 million people, and only in Brazil, and there is more outside Brazil. Every single day there is huge volume of data, and all of their backends were in Kotlin since 5 years ago. So when I arrived at the team, they were already using Kotlin for everything regarding the backend, and their front-end apps were still separated, Swift for iOS and Kotlin for Android, but they were planning to merge them using Kotlin multi-platform, which is KMP for short. Another advantage of using Kotlin instead of Java, it's because it's null safety by default, because it puts the verification of NullPointerExceptions at compile time. In Java, we need to use some not so well thought solutions like optional, because why I say that, because optional arrived a couple of years later on the track. So it's just to prevent this cursed NullPointerExceptions that happening at runtime. So they introduced optionals. But in Kotlin, it's even better, because in compile time we can catch NullPointerExceptions. So it tends to be unlikely to get a NullPointerExceptions at runtime with Kotlin. It's not impossible, but with this approach, it's unlikely. But in Java, it's almost sure that it will happen. Data class. So in Java, we use Lombok nowadays, or we can do everything manually if necessary. In Java, we can generate getters, setters, equals, and so on. It's ineffective. Most modern languages already generate that for us. And if necessary, we can change them manually. Same approach here with Kotlin. We have a data class, and we type 3 lines, for example, for 3 properties. And the getter setters, depending on if it's a var or value, which is an immutable or not, it will generate all these things for us. Most of the time it's going to work really fine. And if necessary, the language allows us to just change what is needed to change manually. So there is a really good approach here in Kotlin, because best practices, approaches, things that modern language do well, they were default here, but not mandatory. And the good things from the previous year, Java is 30 years old, the good things are still here. So it's a really good mix of both of words. Sorry, there is a bunch of dogs here. They are fighting each other. Okay, I think they stopped. Extension functions add new functionality to existing classes without needing to inherit from them. So usually in Java, we need to have a class, and inside of it, we have a method, which is the formal definition of method, a function inside a class for object-oriented programming. But here we have the possibility of dealing with functions themselves outside classes. It's really good because we have this for free, extension functions, and we abide by some of the good solid principles. For example, open for extension, closed for modification. With extension functions, it's really easy to do that. So it doesn't require too much knowledge of the domain. We just need to extend the type with a specific function, and that's it. It's already working and didn't change the type itself. Smart casts and type inferences are also good things from modern approach. And as I said before, they are, for example, less verbosity in variable declarations, val and var. Val stands for value, which is a immutable type, and var stands for variable, which is a variable type. If necessary, we can explicitly define the type, but most of the time we just use these keywords here, and the type inference system is gonna kick in and infer the type of the object or the value that we are initializing, for example. But for those that want to have them explicitly, we can do that. It's really simple. I'm going to show some examples in a few minutes. Full interoperability with Java with no slowdown during compilation. So it's really, like I said before, they both work together really well. Most of the time, no problem at all in using Kotlin or Java. As I have seen in this bank that I have worked and in my own project, we tend to stick with Kotlin because it's really, really good. It's like I said, it's like driving an automatic transmission car. We just accelerate and brake and put on the D, and that's it. We don't think too much about it. We just focus on driving. It's different with Java. With Java, we need to know so many things, so many details. It's good to understand how things work, but after a few months or years, it becomes just repetitive boilerplate code. With Kotlin, we have a new perspective, and we do the same thing, and with the equal quality, or sometimes even better. No slowdown during compilation nowadays because of K2. It's a new compiler that really improves the transpilation process and bytecode generation process. It's practically the same as the native Java transpilation, so it's no noticeable slowdown. There is a bunch of data and tests to prove that. And transitioning to Kotlin is a low risk, high benefits process, and also easy to learn, as I mentioned before. That's really the case. It's not marketing, because if necessary, with IntelliJ, in a few clicks, we convert between themselves. So if we paste Java code in IntelliJ, it converts to Kotlin if you want to. It will ask for us, do you want to convert this to Kotlin, or vice versa? So the IDE itself can do that really safely, and it's really low risk. The language is 100% interoperable with Java, allowing both to coexist in the same project. It's also true. I have seen it in big projects, and that the same applies. We tend to start writing only in Kotlin because it's better. You can call Java code from Kotlin and vice versa. and that's also true, but we tend to just stick with Kotlin when the team gets the feel of it, they are going to tend to prefer Kotlin. A few exceptions, those guys that doesn't like anything new. I don't blame them. But as I mentioned before, it's 10 years now. So eventually it's going to be 20 years, 30 years. So how long does it take to something to not be hype anymore? I still remember some guy that told me that Spring was hype. It's not hype, it's almost 20 years. And it's been working fine in production in so many environments, different scenarios. So it's just a matter of trying. Try this. If you don't like, if you prefer Java, no problem at all. But probably you are going to prefer Kotlin if you were a Java developer, or if you are from another stack, you are gonna find the Kotlin syntax really interesting, really simple to grasp, to read. I'm gonna show you in a few minutes. Okay, let's see. Just real quick here. Safer code and modern ecosystem because of Google. And we have Kotlin multi-platform that allows various platforms to be developed too for Android, iOS, web, and even desktop. I forgot to mention desktop. Now for the best part, I think it's some real code. So I have some real code here. It's in productions almost for a year. There is a software as a service application that I have developed in the past year, and it's in production, and it deals with car items. So some B2B business want to find some car items by code. So stock items by code, that's the name. It's in Portuguese here at the top because the client is Brazilian. The customer is a Brazilian. And here we have the main entry point, the main function. It's very similar to Java, but simplified. I can even remove this if necessary. It's going to work fine because I'm not using any argument from the command line. And that's it. That's really different from the main function for Java. Just for a comparison.
Robson froze for everyone, or just me?
Yeah.
Oh, yeah.
Yeah, I think, yeah.
Okay.
I was just thinking it's really hard about the next 8 to 10.
Java is so heavy that broke his PC.
Oh, you're back. Sorry, Robson, we lost you there for a second. He's gone again.
Sorry?
We lost you there for a second.
Okay, it's okay now?
Yeah, I think so. It's just when you're writing the Java, then it stopped working.
Okay.
Sabotaged you.
No problem. So in comparison to, this is valid Java code. And if I would do the same in Kotlin, it would be like that. That's it. So here we can see a huge difference in the approach. Totally explicitly approach here, implicitly approach here. They will do the same thing, exactly the same thing. I can even show the bytecode, and they will look exactly the same. But for Kotlin, it's easier to do more with less, and not more bad things, because by default, good practices are implemented in Kotlin. So it tends to be harder to make mistakes in Kotlin because it prevents you from doing that. And if you explicitly want to do things manually, you are free to do that as well. So that's just an example. Let me show something else. I have changed this class to this name. Okay. Here I have this project. I really like package by feature, which is a kind of vertical slice architecture in comparison to horizontal architecture like clean code, clean architecture, or hexagonal. I prefer package by feature. I think it's simpler, and also understandable. And it's really a small service, so that doesn't. I think that it didn't need clean arc, for example. So here, stock. When I need to deal with stock, I just go to features, stock, and that's it. Everything is here. I will increase this. And here, stock service, for example, it's the core of the solution because it ingests some stock texts, and it's a huge list of item codes that we need to ingest in the database. So this stock service here is the main thing happening here. It's easy to use the logging framework. It's also lazy by default. So in Java, we need to explicitly think if the logging is lazy or not, because if you try to compute something in the log that takes a bunch of time, it's going to slow down the entire application. Here in Kotlin, we have it for free. We just define this line here, and it figures out if it's lazy or not for us, because it already use a lambda expression and an anonymous function. So this syntax here means that it's an anonymous function, and it's lazy by default. For the Spring framework, everything remains the same. So everything that works in Spring works in Kotlin and vice versa. So here is a notation classically from Spring. At service, it's just a way of making this class into a bin, which is a Spring managed object. So it works the same here. Here we have the dependency injection. So just by using this inside the constructor, this way, it's already done the dependency injection finally through the Spring context. So they are all going to be managed by Spring. Most of the time, that's what we want. And then we can extend an interface. It's just like that. We just use this symbol here and iStock service, for example, and it's an interface. We can extend it whenever we want. In Java, just for comparison, is implements. So a bunch of words here, they simplified to one symbol. Override functions the same as in Java. Another interesting thing that we have here, in Kotlin, we can have default values if necessary. So I can provide a default value here, and it doesn't become mandatory for everyone to implement this size. We can just define a default value here, and that's it. Those function calls that doesn't, but are not trying to modify the size. They are not going to care. And those that want to modify the size by to do that. Ever, they have specific value here. Another interesting thing, yes, this here, it's the null safety thing that I was mentioning. This question mark with this colon key here, it reads like that. If the left value is null, use the right value. So that's a clever way of dealing with NullPointerExceptions at compile time, and it's really concise. It's called Elvis operator, because if we use some imagination, it's like the hair that Elvis had. Elvis operator. Like that. So with that, we prevent a bunch of null pointer in runtime. Here is the lazy evaluation that I mentioned. So whenever we use this syntax here, instead of the classic function call, which usually is parentheses, we can do that if necessary. But if we change the parentheses to this, I forgot how to say in English this symbol, but if we change this to that, it changes in compile time to anonymous function, which is lazy by default. So it's only going to be computed if necessary. That improves performance. The same applies not only for logging, but also for other kind of functions. For here, for example, for collections, we have so many extension functions that are really useful. Aside from those that comes from the Java itself, we have some that comes from Kotlin team. They have created it for us just to be more productive. For example, get or null. Usually in Java, we would need to implement this manually. But here, they have done that for us. So I have accessed the _collections.kt, which is the extension functions to the collection API that Java relies on. It's one of the main ones. And we have a bunch of free functions here to use to improve our development quality of life, let's say it like that. So instead of implementing this if-else statement here, manually in Java, we would need to do that. But as they know that it's so common to need that kind of function of construct, they have already done that for us. So get or null, it's here. We just use it, and it accepts a generic type from the list interface. So as long as it is a list, we can call this get or null. And we have the same thing for other functions that we usually need then. For example, index of first. If you are doing a palindrome verifier or something like that, that kind of interview stuff, we have it here. And in practice, it's just calling this code. So the extension function, as the name suggests, it's a way of extending the functionality upon a specific type, in this case, iterable. And it encapsulates this logic here for us. And there is a bunch of them. It's really huge. This class, this is not the only one. We have other ones that really help us become more productive, not dealing with minor details. They favor implicit development or declarative programming. And again, if necessary, we can do things manually. So there's nothing that forbids us to doing that. Let's see what else it's interesting here. Okay, aside from the code itself, as I mentioned, we can use Swagger. Everything that works in Java, every single library that works in Java works here as well. For example, I need to send some emails here. Oh, there is some things different. They are fixing that, but it's just a minor syntax detail. In Java, in pure Java, we call this @value from this property file here, like that. That's it. But in Kotlin, we need to use this escape character here. I don't know why it's like that. I didn't search about it, but it's just a minor thing. No big issue, and it will read the value from the Spring properties file. Those of you who already worked with Java are familiar with this. It's here, for example, YAML. So those values can be captured from these keys here by using this syntax. Minor difference here between Java and Kotlin, but no big deal. And this library that I'm using, it's Jakarta mail message. So previously it was Java X. Now it's Jakarta because I'm using Java 21. Another important thing to mention, usually they catch up really fast with the major LTS versions for the JDK. So recently JDK 25 was released, and Kotlin didn't have support for 25 yet, but they are planning to give support for this before the end of the year. So they usually tend to catch fast with the latest LTS versions. 21, which is the previous LTS version, is already supported since last year. Okay, testing frameworks. All of them work together, really the same. And we have some frameworks for Kotlin that are specific for testing. So we can use, for example, Mockito and JUnit, no problem. But there is another specific version that it's not called Mockito. It's called Mock, like that. And it's specific for Kotlin. It works best for Kotlin. And it's more concise, more expressive. We can do more in comparison with the classic Mockito. But Mockito also works fine. I'm using it here. But in the future, I'm going to change to Mock because I think it's better. So, but at the end of the day, they will do their job the same way. Here we have some tests. It's really descriptive. For example, in Java, to create a list, there is 4 ways, I remember, 4 different ways to declare a list. Here we just use list off, and it's going to create a immutable list. That's it. And if we need to do the immutable version, we just call it mutable list off. And that's it. I forgot to mention, Kotlin favors immutability. So with immutability, we have thread safety for free. So it's a good thing. Every time we use these val keywords, this value here is going to be immutable. We can apply it put it in a thread pool, for example, or coroutines. It's not going to cause any problem because it's immutable. It's really good. If it was variable, we need to deal with race conditions and synchronization and so on. If necessary, we can use it, but by default, they tend to use immutability whenever possible, even in the collections themselves, not only list, but the other ones as well, whenever possible. Another important thing about here is we have, let me just open a repository. Here, stock repository. In Java, we usually use Hibernate to deal with ORM, object relational mapping. It works the same here. Just a few difference, but most of the time it's going to be the same. So we just use the Hibernate or whatever framework that we need. It's going to map really well to the table, and it's going to be more concise. Here we have an interesting example. 1, 2, 3, 4. We have 4 properties here. In Java, probably it's going to be almost 100 lines. I'm not joking. But in Kotlin, it's just 31, 32. So when I say it's really concise in comparison to Java, it really is. And it does the same thing. If necessary, I can implement all of the getters and setters and constructors here manually, but most of the time it's not needed. It's just boilerplate that we need, just ceremony. And the optimizations that we can do with performance and so on, we can also apply them if necessary. If we can make them lazy or eager and so on, everything works the same here. Okay, we have 20 minutes left. Do you guys want to see something specific in this code or have any question?
So this is a web application, yeah, or is it a backend API Spring app? So there's a backend and a front end to this as well.
Yes, I forgot to mention, we have Swagger here, for example. It's a web application indeed. So it's just classic backend nowadays. I tend to say that backend creates JSON and front end beautifies the JSON. In summary, that's it nowadays, right? So it's like that here as well. So backend just create the JSON, have a code here of one stock item. It's in local host. Let me see if it's running. No, it's not running. So when the running begins and the application is okay, it's going to, oh, here I was calling that previously. So it will return this JSON here, response body. We can change the status code freely, necessary. So it returned these 3 stock items with some additional data and pageable already. And this is the front end. So it's in production. It's the same that the customer still use today. It's like it's a B2B catalog of stock items for cars. It's in Portuguese because it's a Brazilian market. But the idea here is whenever a vendor needs to see if some other vendor has some stock item that they need, they will seek the item code here. And the most interesting thing for them is this number, because this kind of customer, they don't want to buy online. They tend to go to the store physically and buy the items that they need physically. So they just need to confirm, do you have this item here that I need? Yes, I have. How much it is? XYZ. Okay, I'm going to go to your store right now and buy it. Or could you send me, if they trust each other, could you send me somehow? And then they make their arrangements to make the sale. But they only care about these 2 facts: the name of the vendor, which is this column here, and their phone number. And as a third requirement, where they are, if they are near them or not. And in this front end, aside from other things that is happening, the main thing is here. So we search for code, and we can see the call being made here. So that's it. That means stock and code in English, and I pass the code, and it's pageable. Let's see if the application is running. Yeah, it's running. So if I call this, it's going to answer. Okay, it's here. So this response body is the newer one. It's the same as before because I didn't change the code, but there is a few million of code here in this database in production. That's just an example. That doesn't mean nothing to me personally. but it means for the end customer, they really understand this code and what is the vendor and the name of the car maker and so on. And these guys here, they are banners from some marketing stuff that they do. So they ask money to appear, to let the end customer show up their logos here, their information, so they can get new customers. But it's like that. It's just a backend generating the JSON, and the front end beautifies the JSON and make this vision here, this screen and other stuff that's happening. I'm dealing with the magic link, so I'm not storing any password. I'm just sending them a magic link, and they open it in their email address and in their and they access it, and they are going to be logged in this website. And this button here, login, is going to change to upload, so they can upload their items in this catalog. Does that answer your question?
Yeah. So the customers will manage their own inventory levels as well through this.
Sorry, could you repeat the question?
So the sellers of the items, they will manage their own stock levels within the application as well.
Yes, exactly. It's hard to do that. In the beginning, it was hard to define some rules, but the main concern is when they send wrong data, and we need to improve the CRUD management of the items and also the sellers, because sometimes they make mistakes, and right now we need to manually fix these mistakes. For example, the name, or the price, which is this column here, or the quantity, and it takes a lot of time, but I'm planning to create the basic CRUD operation for that. Right now we only have create and read, but we need to have a way of letting them do the update and delete if necessary. So we don't need to deal with that directly.
Okay, cool.
Anything else?
I guess a more general question then about Kotlin and Java. Kotlin's what, 10 years old now? Have you seen, as it's been developed, more of the features being moved over to Java over time as new versions of Java have come out? And do you still think there's a wide enough gap between the value that Kotlin gives you to make it more useful than Java?
The gap is still huge, but we have seen recently and also in the previous years, the Oracle team, they are trying to catch up with Kotlin, because they have understood that they are too slow and people are using Kotlin instead of Java. At the end of the day, it's the same JDK, but it's not good for the marketing and the business. So people are not liking Java anymore, and because they have Kotlin, and Kotlin is far ahead. But Java itself is low because it's their proposal. They like to be stable, to be reliable, to work in production for years to come, and that's it. That's their directive, let's say it like that. But Kotlin doesn't have the same compromise.
Okay. Yeah.
Yeah, I wanted to add a corollary is that technically, at least, there's no reason to use Java in a new project, given what Kotlin gives you. It's just it's a net negative. It's just the only difference is the compilation time. It's the only thing where Kotlin is worse than Java. That's it.
And nowadays,
that's the only. Yeah.
nowadays with Kotlin K2, which is the newer compiler, this difference is not noticeable anymore.
Okay. But
So
that's, if
no reason
it
to
would
use
be a
Java.
compiler that was slower, I will take Kotlin any day of the week. It's just better. Period. There's nothing you can do with Java that you cannot do with Kotlin. There's loads that you can do with Kotlin that you just will suffer if you try to do it with Java. It's just better.
Yes, it is. It's a totally different approach in practice that still relies on the good things from the Java platform. So we need to, I'm not sure if everyone knows that, but Java, it's the name of the language and also the name of the platform, similar to C# and .NET. So, but in C# and .NET, the difference is more noticeable because the names are different. But in Java, there is the Java language and the Java platform, and most of the times people tend to mix them together. But one thing is the Java platform. There are so many good things on it. The other thing is the Java language, and it's falling behind in comparison to Kotlin, for example.
That's one thing also worth mentioning is that it has tail call recursion as part of the language, and it's implemented with a hack. So if you do a function that is tail call recursive, it just creates a loop in the JVM in the bytecode. But it does it, so you will not Stack Overflow if you have a call stack that is too large. So you can safely use recursion without blowing the stack.
Yes, another thing. I usually don't mention that because people don't know what that is.
It's just a lot of little things. It's the suspend functions. It's like the task from .NET, but better.
Yes,
That's it.
The suspend function, there is an interesting data structure behind it, which is the continuity, which is just a data structure that gives us for free the almost like a virtual threads or light threads. So it's almost like the same memory consumption which is in kilobytes in comparison to native threads, but with a data structure. So Kotlin had virtual threads a few years before the Java platform itself. It's really interesting. Clever solution.
I need to open for my door for my son. Sorry.
Anything else, guys? Nope. That's it. Thank you for your time, and hope you guys have liked this presentation.
Yeah, that was really useful. Thanks, Robson. That was really good. All right, I'll stop the recording now. Thanks, everyone.